Today we are going to talk to you about the rearrangements of alkyl groups in the Friedel-Crafts alkylation. The first thing I wanted to introduce you to was the Friedel-Crafts general alkylation problem. And so the first thing we want to notice is that it starts with a benzene ring. And the two solvents we use have to be an alkyl halide and a Lewis acid. The most common alkyl halide we use is chloromethane. And the most common Lewis acid we usually use is aluminum chloride, which is right here. The problem with these Friedel-Crafts alkylation problems is that you have to understand what alkylation means. And what that means is it's transferring alkyl group from one atom to another. So if we look back at our problem up here, we notice that this is the alkyl group right here, and then it's here on the benzene ring. So what happens is it gets transferred from the chlorine to the benzene ring.
Now let's take a look at our main topic, which is Friedel-Crafts alkylation with the carbocation rearrangement. So looking at this mechanism we have right here, based off of the general Friedel-Crafts alkylation mechanism, we would assume that this would be the product we would get. But that's actually not correct. We're going to get a mixture of the product we expect, the 3-methyl-2-butanol-benzene, but we're also going to get the tert-pentyl-benzene. And this occurs because of the 1,2 hydride shift that will happen in the intermediate. Okay, so this type of rearrangement basically occurs using 3 steps. In the first step, we get our alkyl chloride, and it reacts with the aluminum trichloride in order to form this complex we see here. And this complex decomposes into the less substituted carbocation. So in this example, it's a secondary carbon-cation, and we could see right here you'd have an opportunity for a tertiary carbon-cation. So in the second step, we end up getting a 1,2 hydride shift, which converts the secondary carbocation to a tertiary carbocation, which is the most stable. And then in the final step, step 3, you just have the normal Friedel-Crafts alkylation mechanism, where we have the addition of the carbocation in the first part, the loss of a proton in the second part, in order to get our final alkylated product.
So now we're going to look at another example of the Friedel-Crafts alkylation with carbocation rearrangement. So in this first example, we can see that we have the alkyl chloride with the aluminum trichloride, and as Ellen mentioned earlier, you would expect to only get this product over here. However, because of the hydride shift occurring over here, this shifts the primary carbocation to a secondary carbocation because it's more stable. So, because of this hydride shift occurring here, the primary carbocation over here yields this first product that we would expect, and the hydride shift, which causes the secondary carbocation, causes this second product, which leads to 2 products for this reaction. So the most important thing to remember for these reactions is this hydride shift that occurs, the key step that changes it from having simply 1 product that you would expect to 2 products, because the secondary or tertiary, like Ellen did in the previous problem, is more stable than this primary over here.